Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving count and say. So the problem description is kind of hard to understand, but it's basically just literally count and say. So we are basically at each iteration counting and saying the number of each consecutive identical characters and then printing out the character itself. And at base case, where count and say of 1, the string will start at 1, and then we will continue all the way to n. So that's basically what it is. So if we look at this example, if n is 4, we will start at 1. There is one case of 1, and for the next string, there is 2 consecutive ones, so we print 2 and 1. And then in the next string, there's one case of 2, and then one consecutive case of 1. So then we print this as our final string. So now that we have seen some examples, let's get to how we can solve this problem. As stated earlier, the current string will start with 1, and what we will do is while k is less than the length of the current string, and the current string at k is equal to the current string at j, then we need to increment by k. And when they are no longer equal, then we would add the k minus j to the string and also the current string at j to the string. And then afterwards, we will set the current string to the next string, and then we will need to reset j, k, and the next string back to an empty string, and then increment I. And then we will continue this iteration until I becomes n minus 1, and then we can return current as the result. So let's go over this example real quick. So first, we come to k. After incrementing k by 1, it is no longer less than the length of current string, so we will add k minus j, which is 1, and 1 the string itself to next. And now we need to set next to current and reset everything and increment I by 1. So we see that there's 2 instances of 1, so that's why k is equal to 2. We incremented k by 2. K minus 0 is 2, so we add 2 to it, to the next string, and then we will add 1 because 1 is the string that we are counting. And then now we need to reset everything again and increment I. So now we come here, we increment k by 1, and then they're no longer equal. So there's one instance of 2. So k minus j, 1 minus 0 is 1. So we add 1 to the next string, and then we add 2 because that's what we are adding. And then we move on to the next string. So k minus j is now equal to 1. So one instance of 1. So that's why we added. Oh, and by the way, when we move to the next string, we need to set j to k beforehand. So that's why j became 1, because beforehand k was equal to 1. So we set j to k, and then we increment k, and then that's how we got here. So now we need to reset everything again and set next to current. And now I is equal to 3, which is n minus 1. So we can return this as our result. So the time complexity would be O of 4 to the n divided by 3, because as you can see here, as the n gets bigger, it will increase, but each string initially after 3 iterations will only become 4 times larger at the very most. So that is why it's 4 to the n minus 3 at worst case. And the space complexity will also be O to the 4 of n divided by 3 for the same reason, because the next string can take up that much space. So now let's get to the coding part. So first we will set current to 1. It's just the initial case, and then now we will loop through for I in range all the way to n minus 1. Initialize the next string to empty string, and j and k will also be initialized to 0 as shown in the example. And now while j is less than length of cur, and while k is also less than length of cur, and current of k and j are equal, then we need to increment k by 1. And then now we can add it to the next string. So string of k minus j plus current of j. And then we can set j to k. And then we can set current to next. And then now we can return current. And let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave down in the comment section, and I hope to see you all again soon.